Yes. 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 Email me, and then we will go back over them on Tuesday. Huh? Yeah. No. Well, Monday and Tuesday. No. There's junior high games from starting at 12. High school starts at 6. Yeah. 7 and 8. 15, 16. No. I took London's. So guys, 15. So the hypotenuse, so a squared plus b squared equals c squared if it's a right triangle. Our two sides are 65 and 72. And the hypotenuse is 97. So what we want to see is do 65 squared plus 72 squared equal 97 squared. Now 65 squared, well, be helpful if I square it, plus 72 squared equals 9409. Now 97 squared, we can plug in a calculator, 97 squared is 9409.
So was that, I was making it so much harder than, I don't know what the frick I was doing, but I made it so hard.
So since they are equal, it means that it is a right triangle.
Am I allowed to change that?
Yeah. So you can go back through and fix those or recheck them. But then 16 and 17, those are all the same. Does that make sense? C is greater. And if C is less, it's acute. Any questions on this here? Okay. Now what we're looking at today is sine, cosine, tangent. And yes, we did skip several sections. Now, the reason we did this is because we've seen that it's going to be easier to go over sine, cosine, and then eventually we're going to do tangent first, and then go back to 9.2 and 9.3. So, what we're looking at today is sine and cosine functions. Now, these here are the graphs of sine and cosine functions. Now, the sine and cosine functions are given a specific name. They are called periodic functions. Periodic, they repeat themselves. There is a certain period that they repeat themselves, and sine and cosine repeat themselves what we consider every 2 pi units. It is what the period of each of these functions is. Makes sense so far, yes? Not too bad. Yeah, period. So sine and cosines, period, is 2 pi. Now, specifically for these here, the sine and cosine, we're only really going to look at the functions on the interval of 0 to pi over 2, or really 0 to 90 degrees. Because we're only looking at sine and cosine for this here, at least for this chapter, in a right triangle. So the angles that we look at them are going to be between 0 degrees and 90 degrees. These here. Now, 90 degrees for sine and cosine really is not going to mean a whole lot to us, mainly because for cosine of 90 degrees, its value is 0. And at sine of 90, its value is 1. Now, that's really the last we'll see of the graphs. We're mainly going to just look at it in terms of the triangle. Sine and cosine ratios. Sine and cosine. Let ABC be a right triangle with angle A with acute angle A. Sine of angle A, so sine of this, and cosine of this are written as sine of A and cosine of A. And we define them as following. Sine is going to equal the opposite side over the hypotenuse, and cosine is going to be the adjacent side over the hypotenuse. So sine of a given angle is equal to opposite side over the hypotenuse. And cosine of angle A is equal to the adjacent side over the hypotenuse. And the hypotenuse is always going to be the longest side. Now the adjacent side and opposite side are going to be dependent on the angle. So for angle A, this side over here is the opposite side. And this side here is the adjacent. Now if we're looking at angle B, over here, this side is now the opposite side. And this side here is now the adjacent. Because it's all in terms of the angle. Because when we say opposite side, we're saying the side opposite that angle. The side farthest away from it. And when we say adjacent, we're saying the side that is next to it. And the hypotenuse will always be the side opposite the 90 degrees. All right, so let's look at and see how these work. So we want to find sine S, sine R, cosine S, and cosine R as fractions and as decimals rounded to 4 places. So we're going to look at sine of angle S first. Now again, sine of a given angle is equal to the opposite side over the hypotenuse. And looking at this triangle here, which of the 3 sides would be the hypotenuse? 65, because 65 is opposite the right angle, yes. For a right triangle is the 90 degrees. So here, 65 would be the hypotenuse. And no matter which angle we look at, 65 will always be the hypotenuse. So for sine of S, opposite side over the hypotenuse, well, the hypotenuse is 65. Which side would be opposite? Because we're looking at angle S, and the side farthest away from it is 63. So sine of S would be 63 over 65. Questions on this here? Now, for a decimal, we can say 63 divided by 65, which is 0.9692. If it asks for it. Yeah, since it asks for fraction and decimal rounded to 4 places, we have this here. Question on sine of S. Let's look at cosine of S. In cosine of a given angle, theta is just a given angle, is the adjacent side over the hypotenuse. So if 63 was opposite, what's going to be adjacent? So it's going to be our side length ST or 16 because it's right next to that angle. And the hypotenuse is still 65. And again, we can take the calculator and do 16 divided by 65 and get 0.2462. Any questions on this here? We good with this here so far? Okay. Now we also need to find sine of angle R. So sine again is what? Opposite over the hypotenuse. So angle R, what's our opposite side? 16. Because again, the opposite side is always relative to the angle. Since we're talking about angle R now, the opposite side is 16. And the hypotenuse is 65. So what's this as a decimal? 2462. Cosine of angle R is adjacent over the hypotenuse.
So is it the same thing as
Yes. So adjacent is the side opposite the angle, and the hypotenuse will not be the adjacent. So 63. And hypotenuse is?
0.9?
Yes. And we will eventually have the theorem that explains that. Yes.
Felix, is that?
Who?
Is that?
No idea. Questions on this here? Let's look at this one here. Sine of S, sine of R. So we'll do sine of S and cosine of S first. So sine of S, sine is opposite over the hypotenuse. So for angle S, the opposite side is 4 over the hypotenuse, which is 5. So we need to do 4 divided by 5, which is 0.8000. Yes. Because sine of an angle is going to be opposite over the hypotenuse, and cosine of an angle is going to be adjacent over the hypotenuse. Now cosine of S, so the adjacent side would be 3, the side next to it, and the hypotenuse is still, and this as a decimal would be 0.600. So it's all relative to the angle. So here, we know 5 is going to be the hypotenuse because it's opposite the right angle, yes? Now, angle S, what's closer to it? Side ST or side RT? ST is right next to it, yes? So it's adjacent, and RT is opposite. Adjacent, next to. Because when we say something's adjacent to another, we're saying that it is next to it. Because we can say you were adjacent to Gracie, or Grace, because you're right next to each other, yes? Because that's adjacent. Because right now, we're opposite each other. We're away from each other. So that's the same with sides, because angle S and RT are opposite. They're farther away from each other. Now, let's look at it in terms of R. So sine of R. So R is this angle here, yes? So which side is farthest away from it? Which will be R3. So that would be the opposite side. And the hypotenuse is? So we get, as a decimal, 0.6000.
So is it always going to be like?
Now cosine of R, the side that's next to it is the 4. Yes, especially 0 to 90.
This is kind of awkward, but you know what it is?
What's that?
So like, if you look at the triangle and like you have two, if you look at it,
Mm-hmm. The Pythagorean triples? Yes, as long as the two smaller are the two sides and the hypotenuse is the biggest. Questions on this here so far? So let's look at this next one here. Find sine of angle D. And we're going to find cosine of angle D. We'll do these first. Now, looking at the three sides, which one is going to be the hypotenuse? 25, because it's opposite the right angle. So for sine of angle D and cosine of angle D, the denominator for both of these will be 25. Now for angle B, which side is opposite? 7. So sine, which is opposite over the hypotenuse, would be 7 over 25. Cosine is adjacent over hypotenuse, so it would be 24 over 25. Now on the calculator we can do 7 divided by 25, which is 0.28. And we'll add 2 zeros so it's rounded to 4 decimal places. Then we can also do 24 over 25, or 24 divided by 25, which is 0.96. So this is equal to 0.9600. Sine of f, opposite over hypotenuse. Well, the opposite side, the angle f is over the hypotenuse, which is going to be 0.9600. And cosine of angle f is going to be adjacent, which is 7 over and that's it. It's just wanted rounded to 4 places, so we add 2 zeros to get 4 decimal places. I'm not going to count off. Questions on this here? We good with this here so far? Do we need to see another example of one of these? If we're good with these here. Adjacent is next to, yes. Sine and cosine are complementary angles. Sine and cosine of complementary angles. Let sine of an acute angle be equal to the cosine of its complement. The cosine of acute angle is equal to the sine of its complement. Let A and B be complementary angles, then the following is true. That sine of A is equal to cosine of 90 minus A. Well, let's look back at what we had. So really what this is saying is that if we have one angle, the other is true. Now, let's go back one. This here. In this triangle, let me erase a lot of the writing. This is a right triangle, yes? So we know all 3 angles in the triangle have to add together to be 180. If we know one of them is 90, angle D and angle F have to add together to be 90 degrees, yes? So, angle D, because plus angle F is going to equal 90, yes? Or if I subtract angle F from both sides, we get that angle D is equal to 90 minus F, yes? So cosine, as we just said, of angle D is equal to sine of 90 minus angle D. That's the theorem that they gave us, yes? Because, let me go forward too. Sine of A, or here, cosine of angle D is equal to sine of 90 minus A is equal to sine of B. Here, sine of angle D is equal to, well, 90 minus F, because 90 minus that angle for these two to match. That's also why sine of angle D is equal to the same thing as cosine of F, just for those to be the same. The same is true for sine, because if those two angles, for them to be the same, 90 minus that angle gives us the comparison. So, write sine of 56 in terms of cosine. So, sine of A is equal to cosine of 90 minus. So this is the same as cosine of 90 minus what is 90 minus 56?
So it's just plug in the numbers.
Yeah. Yep. So sine of 56, I'm going to show you this here, is 0.829037573. Cosine of 34 is the exact same thing.
That's what those are on the calculator.
Yes.
So we can just plug it into the calculator like that to check our work afterwards. Make sure we got it right.
Sine of 43 in terms of cosine. Well, sine of 43 is equal to cosine of 90 minus.
I love it.
You start adding on the ratios of letters into this. Or are there no letters?
There has to be letters somewhere. Or there's like squares or something. Or like you have to like square it or something.
If this is it, we're safe.
Questions on this here? All right, write cosine of 23 in terms of sine. Well,
Start at cosine instead of regular sine.
so guys, let's focus in. So cosine of A is equal to sine of 90 minus A. So cosine of 23 is equal to sine of 90 minus
My brain is the math.
questions on this here. So cosine of 12.
Cosine of 12 is equal to sine of 90 minus 12.
Any questions on this so far?
Well, I forgot. When you started explaining it, it was like so much more confusing. All the letters, and I was like,
I was so
I was doing it now.
Questions on this here?
Why is the 12 blue? Oh.
Yep. Do we feel good about writing it from sine to cosine, cosine to sine?
316.
That's not bad.
3 through 16. Because 3 through 8 is sine, cosine, write it sine and cosine as a fraction and decimal of both angles. 9 through 12 is rewriting it as sine to cosine. 13 through 16 is going from cosine to sine. Now, I will say one thing, and one thing that's kind of interesting. If we look at this here, guys, almost done, almost done. Now looking at this graph, because we said sine of an angle is equal to cosine of 90 minus that angle. So here, sine's value is 0 on the y-axis. If we go over to 90 on cosine, which is, where am I looking? So 90 here, pi over 2 is 90. It is at 0. They actually match back up. Here is the length of their difference. And when sine or cosine's at 1, here at 90, sine is at 1. Their graphs are 90 degrees difference, or 90 measured different, shifted one way. Because I will show you this here, so clear, yeah, sine x, cosine
And we can make those at our calculator, right?
yes. Mode degrees. Really,
I know it was.
yeah.